Well, we're starting off another new chapter. Oh, yeah, go us. We're so smart. We can do another one. Arithmetic sequences. We have sequences and series for this chapter. We're starting off with arithmetic, which you have seen before. So, arithmetic sequences, when I'm looking at this, is basically saying I'm starting off with 1, I'm looking at the pattern, and I'm adding the same number each time. When you're adding the same number. A to the first, that's saying your initial condition, what you're starting with. This is a recursive formula, meaning that we can plug any number into this equation to solve for it. This is the equation that we're actually going to be using today, so I might want to put a little box over this so that you remember whenever we're going to be looking for a recursive sequence or recursive formula so that we can help find the next number, which we'll get into. So arithmetic, first we have to say, is this arithmetic or not? How do we check? So I'm starting off with 3, and then I go to 6, I add 3. And then I go to 9, I add 3. Add 3, add 3. So yes, this is arithmetic because I'm adding the same thing each and every time. So this would be D is equal to 3. And now I'm going to find my recursive sequence. So when you're looking at that equation, I can say a to the nth. So a to the nth, I'm going to say a to the first. I'm starting off with 3. Is equal to, and then it has whatever a is equal to, so that's your initial, so that would be equal to 3. And then plus, and then we have this n minus 1 in parentheses, and then whatever our d's, or our differences, which is also 3. So then we solve, this should say a to the n. A to the n is equal to 3 plus, I distribute this 3 to both terms, I get 3n minus 3, combine these two like terms, get a to the nth is equal to 3n. You can always try just to make sure that that's right. Let's check. I have my 1, 2, 3, 4. My fifth term should be equal to 15. So if I plug 5 in for n, because it's my fifth term, I get 15. So this checks out. Go us. Next one, is this arithmetic? Here I'm adding 3. Here I'm adding 5. Here I'm adding 7. So no, this is not arithmetic. So I don't have to do anything else. Bummer. Next problem. I'm looking for my 100th term here. What I'm given here is my first term, which would be 6, and my second term, so that's why it's a 2 right there, which would be 11. Knowing that, I know my difference here, what did I add here, would be 5. So first thing I'm going to do is find my recursive formula, So my a to the nth is equal to whatever I start out with, your first term, and then adding n minus 1, and then be a 5, because my d is 5. So a to the nth is equal to 6 plus, distribute that 5 to both of them, so 5n, subtract 5, and these two are like terms, so a to the nth is equal to 5n plus 1. Again, I can check. If I plug 2 into my equation, is it equal to 11? If I plug 2 in. 5 times 2 is 10 plus 1, that works. So now I'm going to use that to figure out my 100th term. So putting a little 100 here because that's my 100th term. And now I can do 5 times 100 plus 1. So it would be 501 would be the value of my 100th term in this question. B, I'm looking for my second and third term. So if it's already telling you it's arithmetic, that means you're adding the same thing each time. So I'm adding D here, I would be adding D here, I'm adding D here. So I can set up a little equation because I know that 82 should be equal to 100, subtract, and I have 1, 2, 3 D's. I know for sure that should work. And now this is just an algebra question. So subtract the 100, you get negative 18 is equal to negative 3d. Sorry, that should be a plus because you're adding each time. And then divide by 3, I get negative 6 is equal to d. Because each time you should be adding something. So in this case, I'm adding a negative 6. So now I'm looking for my next two terms. I take 100 and I subtract 6. So my second term would be 94. And I take 94 and I subtract 6 again for my third term and be 88. So I want you to do C and D by yourself. Here I'm just going to do one of them and then you can do the other two. So first I'm looking for my D, my difference. So my D would be equal to a positive 3 here. Again, my a to the nth, you want to find your recursive, is going to be whatever I'm starting off, which is 34, and then adding n minus 1 times whatever your d is, your difference. So a to the nth is equal to 34 plus 3n minus 3. So the a to the nth is equal to 3n plus 31. I'm asking for the 32nd term. So you plug 32 into that equation, and you should get that the 32nd term, so that's why you have a little 32 right here, is 127. Do B, C by yourself. And now we have what we call an arithmetic mean. So if you're just missing one term, right, this only works for a mean, you should already know when you're finding the mean, the average, you add the 2 up and then divide by 2. It's going to be the same thing when I have my arithmetic mean. If I'm missing only one number in between here, I can add these 2 up. So 15 plus 59, because it should be the same on both sides, you're adding d on both sides, divide by 2. So if you did that, you know your arithmetic mean would be 37. I want you to find the arithmetic mean for B and C and then a little ABC. And then you have a great, grand, spantacular, made that word up just right now, time of your life right now.